Alright, today I'm going to be talking about scientific computing and the website that I created to describe scientific computing. So pretty much just to start off, this is my index page. Pretty much leads to all my other pages that have to deal with scientific computing. It has a table of contents. It also has the current date, Monday, May 9th. And this is done using a JavaScript code. Along with that is the title, the author, and a little logo that I created using Pixlr while in class and out of class. It goes down to the abstract, which I just briefly describe scientific computing, and then again the table of contents, which leads to all 5 pages: the purpose page, the effects and impacts, technical aspects, relationships to data, and then finally references. I pretty much made this page strictly using the HTML code that was on the cPanel site, uh, following tutorials and just the lessons in class. It was relatively easy, straightforward, simple. The logos and all the background designs were created in Pixlr using a bunch of different tools, layering, shading, um, and just other coloring tools, and pretty much created all the things that I needed to make a purposeful web page. So it's on its way so far. And then onto the purpose page we go. So as we see, to start from the top, we see the logo once more, not animated, just the single image. And then along with that, we see my background. And these were both again created in Pixlr. And as we go down the page, see purpose, and then the first question, which is pretty much asking us to name the innovation and then provide a description. And this is easily done. Obviously, you guys would know it'd be scientific computing. I said it plenty of times before. And to describe it is pretty simple. What scientific computing is the use of high-powered computers to calculate large data sets that have to deal with very specific problems relating to either scientific background or ethical backgrounds. And the reason it has to go through supercomputers is because the data sets are usually ginormous and impossible to model through in just regular computers, especially through hands alone. So with these supercomputers, you can create simulations and 3D images like this over here with large amounts of data sets that we wouldn't be able to understand with just by just looking at the numbers that we have. And these supercomputers, like these computers right over here, and sometimes just by themselves they can take up whole rooms, just being made up of single or of just made up of processors, insane amounts of processors that are used to go through the data very quickly. And scientific computing allows for many different theories to be discovered, and just our common knowledge of these theories to be um, enhanced, because without these computers and the processing power, we wouldn't have any way of creating simulations that would be able to understand and display the data for us to understand. And then lastly, we scroll all the way down to the bottom where we see these 3 buttons: previous, home, and next. And these are going to be they're not just unique to this page. They're going to be in every single page, but describe them now. They're just 3 buttons. They go to the next page and to the previous page, and then home back to the index. They are also created using CSS and the HTML code, and they'll take us to the next page. On to the impacts page we go. Again, we see 3 more questions. First one being B, explain the benefit or harmful effect of the innovation. And this one's obviously easily relatable to scientific computing because um, scientific computing tests almost all theories that we have that are um, very big theories that require simulations. And there's really no negative effect of this. Pretty much just hypothesizing and then putting to test the data that we collect. These theories range from very obscure theories like chaos theory or complexity theory, and they really just test what hypotheses we have around the world. And then on to the next one, explain the impact of the innovation it's had on society, economy, or culture. And This one again very relatable to scientific computing because it is used in everyday life. If you do check the weather or go to the bank, both of them compile very large data sets and require huge computers to go through the data and provide averages or just data that we can interpret ourselves without having to go through all the data beforehand, the raw data. And so this new regular data can be interpreted very easily. And then the same as while watching the Weather Channel, we see those simulations, the green splotches that are across um, the screen that go across the screen, that move across the screen. Those are just simulations of large data sets that have been compiled. And then lastly, question D, indicate one field rather than other than computer science. And again, lastly, one more question that's very relatable. It has to do with math. Obviously, it would have to do with math just because there's huge amounts of numbers, and it doesn't always have to just be raw data that we're compiling. It could be data that has to do with equations that are just ginormous, and you can't just compute every single aspect of the equation in one go, or you need more than just a single processing computer to handle all the numbers that you have to put in. Um, that's the kind of stuff where you need scientific computing to be there to be able to help out in those situations, and that's why I would change the math field because we would be able to do very high complex problems just a lot simpler, more simply. And then on to the next page we go with these three buttons. All right, so as we move forward to the tech page, um, as you can see, there's a video on this one. We'll get to that. We see the first question, E, which describes how a user interacts with the innovation. And pretty much, we don't physically interact or do the innovation daily or in general. It's mostly has to do with scientists and researchers and people that would need it. If you would need to do scientific computing, you would know if you need to do scientific computing. And they pretty much take all the raw data sets from the research or whatever they're doing and input that information into those supercomputers. And uh, it's not as straightforward as anybody would really think. The supercomputers are designed to take in information for each specific experiment. You would say they have specific programs that are ran for the specific experiment that they want, and that's where the data goes in. So it's not just a plug and play kind of every single experiment can fall into the same category. Each one is specifically designed so it works the exact way they want it to, and that's why it's really hard to explain how each one would react to just using it. But in the end, it should all just end up being the same, where they get some sort of um, data set that's very concise and to the point and describes exactly what they need to look at. And we see this video. What is computational science? It's pretty much it just describes exactly how the user would interact and how it works, just in general. Um, but as we go into the second question, describe in detail the innovations technology incorporates at least one of the big ideas of these big ideas. And with scientific computing, it's really based heavily off of the algorithms and programming. It doesn't have to do anything with abstraction or the internet in general. Mostly because the internet just has literally nothing to do with it. And abstraction, it's not easy for anybody to just get into scientific computing or understand it. It's a very complex subject, and that's why it has to do with a lot of algorithms and programming. With the algorithms, we they use just it can the algorithms range from very basic, like even just algorithms used for solving a Rubik's cube to very complex algorithms that we like. I would not even be able to understand how to explain, and they're used for condensing the data and then displaying it in these simulations. And the simulations is where it comes where the programming comes into play because with these simulations, almost each program is designed uniquely for whatever simulation you're trying to design. There isn't just a program that just makes simulations. So that's why it's very unique and relied heavily on. and that's why those two are the biggest big ideas. So as we go on to the next page. Okay, and onto the data page we go. Um, as again, we see for the third time, two questions. G, describe how the innovation consumes data and produces data and or transforms data. We've already gone over this a couple times, so it's pretty straightforward. Um, so with scientific computing, pretty much the scientist or research would take raw data that he's collected in some way, shape, or form through surveys or some way, and he takes that, whatever it has to do with whatever topic he's researching, whether it be something that has to do with nature, uh, some ethical problems, something along the lines of that. He takes that data, puts it into a program, most of the time specifically designed for whatever research he's doing. It's another program, and the program will, or the computer will, understand that what the program's asking for it, compile all the data, do whatever the program's asking for, and the computer will just follow, um, and then eventually producing a simulation or just a less or more easily interpreted data that we can view ourselves. And this is exactly how the um, innovation works. It just takes the data, compiles it into a more viewable, a more interpretable simulation or data set, and then shows it to us. And then as we scroll down, we see the video actually created beforehand. It pretty much just describes scientific computing. So we'll watch that right now. All right, so yeah, me and my friend actually collaborated and took this together. We used his iPhone because my phone actually doesn't even work like that. It was pretty straightforward. Just to describe exactly what it is. Um, and then on to the next question. Describe at least one concern about the innovation. And uh, with scientific computing, there's no straightforward data storage or concern like that. There really wouldn't be um, a situation where data would be compromised in any way. The only way that some sort of security reason would be to occur was if one of those supercomputers that was used are taken control of somehow and then used for um, malintent, like decrypting or deciphering encryption keys and stuff like that, crazy stuff like that, which wouldn't really have to do much with scientific computing, which is why there's not really any concerns that have to relate it. It's more of a research and study kind of concept. But then we go on to the next page. All right, lastly, we're on the references page. Pretty much it is just all the data sources that I used to get the information to make the website. So pretty much, I mean, obviously the first one, Wikipedia, one of the bigger data sources. I got most of my information from this site in particular, so it was very helpful, and that's my website. I really appreciate you guys watching and watching the video and looking at my website, and I'll probably throw in a link at the end to so you guys can explore it on your own. Thank you very much. Bye bye.